Hey yo, we're back. Last time we talked about 12.2, which was the SSS and the SAS triangle congruence. Today we're going to do two more, ASA and AAS, so angle side angle and angle side. Alright, so it says you already know that triangles are congruent if two pairs of sides in the included angle are congruent, so SAS, side angle side. We can also do that using different groupings of angles and sides. You can prove that two triangles are congruent without having to show all corresponding parts are congruent, so we don't have to show everything is congruent. Similar to the SSS or SAS, we only had to show those three things. So today we're going to talk about a couple more. So the next one is the angle side angle postulate. So this says, similar to the SAS, side angle side, it's just the opposite. This says if two angles and the included side of one triangle are congruent to two angles and the included side of another, then the two triangles are congruent. So in this one, the side has to be between the two angles. So for example, we have angle A here, angle C here. We know those are congruent to angle D and angle F, respectively. And then we have that side AC and DF. And those two sides are in between those two angles. So we do have angle, side, angle. Angle, side, angle. So if we have angle, side, angle, then we know that everything else is congruent. So the two triangles are the same size and same shape. Okay, so you can add that to your list of postulates. SSS, SAS, and now ASA. This one says, which two triangles are congruent by angle, side, angle, and explain. So if we look at our three triangles here, two of them have the side in between the two angles, and that is this one right here and this one right here. See this side right here? It is congruent to these two sides, but it is not in between these two angles. Okay, that side would be this one right here. That's the one in between the two angles. So this one does not work right there. So it's got to be these two. And if you want to write the triangle congruence statement, you could write something like triangle ONE. I'm looking at that one. Is congruent to triangle. I need to erase some of this. O goes with V because it's got two things, so triangle V. N goes with S because they don't have anything on there. And then U, VSU. Okay. So those two triangles are congruent by angle, side angle. Okay, so you have the two angles and then the side that is in between the two angles. So this is different than side angle side, it's just the opposite actually. Okay, so I'm going to have you try this one. I want you to choose the two that are congruent by angle, side, angle, very similar to the last one we just did. So go ahead and pause this in 3, 2, 1, pause. Alright, so it should be the two outside triangles, HOG and ATC, because the side is in between the two angles like that and that. Okay, and notice that that side with the 1 mark is between the 1 mark and the 2 mark on the angles. So the 1 mark is here on G, 2 marks on H. 1 mark here, 2 marks here. So though that included side is between the same two angles. This one again, your angle or your side is outside, it's not included. If it was this, then we could say all three are angle, side, angle, but that one is on the wrong side. Alright, next, writing a proof. So again, we're not really writing formal proofs for now, but we can just answer the questions. It says members of a teen organization are building a miniature golf course at your town's youth center. The design plan calls for the first hole to have two congruent triangular bumpers. Prove that the bumpers on the first hole, shown at the right, meet the conditions of the plan. So we basically just need to show that those two triangles are the same size and same shape. So this one right here, and this. Okay, I paused it on accident again. Whoops. Maybe I didn't resume it. I don't know. Anyway, this one says members of a teen organization are building a miniature golf course at your town's youth center. The design calls for the first hole to have congruent triangular bumpers on each side, as shown to the right. Prove the triangular bumpers are congruent for the first hole. Okay, so we're looking at these two triangles. That one and this one. We want to show that they are the same, congruent. Same size, same shape. So to do that, we have a couple markings on the triangle already, which is good. So we know that the angle B and the angle E are right angles. That means those are congruent. So we do have one angle already that we know is congruent. So angle. And then we have the side here and the side here because they have the mark on it right there and right there. So the side is congruent. And then also this angle right here, angle A and angle D are congruent. So angle side angle shows us that these two triangles are indeed congruent. And now that we know that, we could actually say that everything else in those triangles are congruent as well. So for example, this long side right here is congruent to this long side right here. BC is congruent to EF. And then angle C right here is congruent to angle F. Now we can say all those things now that we know that it's congruent. But actually you only really need the first three things. So you only need those three things to show that the triangle is congruent. Okay, so angle side angle works for this one. You can also use side 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 or side angle side. Okay, let's look at this one. We want to show that they're congruent. So again, we have two right angles, B and E. So that tells us that angle B is congruent to angle E because they are both right angles. We know that the two sides are congruent, AB and AE, because it's actually given right there. And then we know that these two angles are congruent because it's also given right here. So again, we have angle side angle. So that is true by angle side angle. So we know those two triangles are congruent by angle side angle. Okay, the next one we're going to talk about is similar. It's the angle side theorem. Now this one is a theorem, not a postulate, because it's a little bit less obvious. This one says if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. So this one doesn't have the side in between the two angles. It's actually a different side. So if you notice, we have our two angles here, A and B. It's congruent to D and E, respectively. And then we know that AC is congruent to FD. Now, those two are corresponding sides because they're both next to the A, which has one mark, and D, which has one mark. So those two sides are corresponding. So what the angle side theorem says is if we have two angles and then another side, another corresponding side, then the triangles are congruent. Okay, so indeed we have the two angles, B and A, and E and D, and then the non-included side, which would be AC and DF. So we can say that by the angle side theorem, the two triangles are congruent. So this is different than angle side angle, because angle side angle would say, we would have said this side is congruent to this side. Okay, if that was the case, then it would be angle side angle, and we were ignoring this and this. Okay, but because it's not included in between the two angles, it's actually, we can use angle side. Alright. Okay, we'll skip over this proof now, and that one. Okay, so next, this problem, let's look at A here. It says your given information is that S is congruent to Q, which is actually drawn on the picture. S and Q are congruent like this. They both have one arc. And RP bisects angle SRQ. So remember, bisect means cuts it in half. So that means this angle right here is going to be the same as this angle right here. Okay, so we know those two angles are congruent. And then they also share a side. So this side right here, PR, is the same in both these triangles. So actually I should make two arcs here because we already have one arc on the other one. Okay, so we can prove these two triangles are congruent by, we have our angle, we have another angle, and then we have the side that they share. Angle, side. So these two are congruent by angle, side. Okay, not angle, side, angle. Oops. Yeah, angle, side, angle would be this one, or angle, side, angle would be this. Okay, the side would be in between the two angles, and that is not the case in this one. We're looking at the red. So it's angle, angle, side. All right. A couple more. It says, use the diagram to the right. Which of the following statements best represents the answer and justification to the question? Is triangle BIF congruent to triangle UTO? Okay, so they both have two congruent angles and a congruent side. Okay, so we have B, which goes with U. We have T, which goes with I. And then this side is congruent to this side. So we do have angle, angle, side on both of these. However, if you notice, this side FB is not corresponding with this side TO, because B has the 1 mark on it, whereas T has 2 marks on it. So those are not corresponding sides. So these two are not corresponding. Okay, so even though they're both angle, angle, side, that side needs to be in the right spot. Okay, so because the side is next to the 2 angle here, and it's next to the 1 angle here, it's next to 1 here and 2 here, those are not the same. So we can't say that these two triangles are congruent. So the correct answer here would be B. FB and OT are not corresponding sides. If it had said FI instead of this one, then it would be true because it's the next. I'm not sure where this stopped again, but these two sides right here, I feel like I should probably explain this again, just in case I missed it. Obviously the answer is B because I just pressed play for you. But if you look, we do have angle, angle, side on both of these. Because B goes with U, I goes with T, and then we have these two sides which are congruent. However, if you notice, look at this side and this side. This one, the top one here, the side that it's touching, the angle that it's touching is the first one. It's the 1 arc. It's B. This angle down here is T, and it has 2 arcs on it. So these are actually not corresponding sides. Okay, even though they're congruent sides, they're not corresponding. So these two sides right here, they're not corresponding. Okay, so if they're not corresponding sides, then we can't use the angle, angle, side theorem. So we'd say no, FB and OT are not corresponding sides. So even though they're both angle, angle, side, it has to be the correct side. It has to be the corresponding side. So if it was down here and down here instead, that would work because they're not corresponding sides. Because I'm not sure why this keeps pausing, but anyway, we're going to move on to the next one. So this one, it says, is triangle PAR and triangle SIR congruent? Explain. So if you look at this, we only have one angle and then one pair of sides, one pair of angles and one pair of sides. However, if you remember, these two angles right here are vertical because they form an X. So we actually know that this angle is congruent to this angle. And I have to use 2 because I've already used the 1 on the A and the I. So now, again, we can use angle, angle, side. Angle, 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 side. So these are congruent by AAS. Okay, if we look at number 7 down here, you have 2 angles, and then they actually share this side right here, so I can put that line. And this one is actually going to be angle, side, angle, because the side is in between the 2 angles. So yes, angle, side, angle, because you have your angle, then the side, and then the angle. And then the same on the opposite side. So that one is congruent by angle, side, angle. The first one is by angle, angle, side. So make sure you can do the difference, you can tell the difference between those two. Alright, and that is all I have for 12.3. So please watch the, or hopefully you watch the video. Please take the quiz, and then come to school. And I'll see you all there. Alright, peace out. Skillet.